start then. Okay. Yeah. Let me
sir,
share
you are live.
My slides. Okay. Let me share some slides. I have got the share permission. Okay, fine. Screen window or this one. Okay, so this is entire screen. Where is entire screen? Windows entire screen. Yes. Okay. Then it is entire screen share. Okay. Now I am going to share my screen. Then I can tell something about program. Okay. And we have covered up to how many lectures? This is more. Okay. Assignment 4. No, assignment 4 is okay. But up to what lecture you have covered? That means up to 10 maybe. No? Okay, PPT is okay. Let us go to that. So, yes. Are you able to see my slide? Hello? Are you able to see? Yes,
Yes, sir,
okay.
we are able to see your slides.
Right. So this is course about mechanics of machining, in which we are telling about how the machining takes place. We talked about main textbook is that book by G.K. Lal, and then there are other books also. Okay, so we have covered till now these lectures, and in which we have given assignments also. Mechanics of machining. We told that what is machining, subtractive manufacturing process, and against the additive manufacturing process, like you have 3D printing, that is additive, but we are talking about subtractive. So these are some basic examples of different type of processes like metal forming, casting, powder metallurgy, additive. But our focus is on subtractive. So we started with that simple mechanics question, that why the tool is of wedge shape. It is having included angle because the force gets amplified. If you apply P force here, then you are getting normal force as P, N is equal to P by 2 sin alpha. Okay, so that's what that smaller the alpha, more amplification you will be getting. So this concept has been told. And in this chapter, we talked about what is mechanics. We talked about some properties of the material, stress-strain diagram, fracture, and then we talked about two stress and two strain concept. Yes, how you can convert nominal strain to two strain. In this, we have given assignments also. Okay, that is this one. And about plastic deformation, strain hardening, different type of strain hardening rules. Okay, then Bausinger effect, and many things. About something about inside it happens, dislocation, etc. But we are not going much detail about that. So this is the first lecture. And then second lecture was this one, mechanics of machining, concept of plastic deformation. So we are telling about some criteria like Tresca yield criteria and von Mises yield criteria. So this criteria has been told, and we are talking about principal stresses, about that dislocation, some more concept about just dislocation, how it happens, but we are not giving much questions. Maybe one or two theoretical questions on dislocations may be asked in the exam. But then coming the lecture 3, that is we come to the machining process. So there are different type of processes: single point tool operation, turning, boring, shaping, planing. Multiple point operations means milling, drilling, typing, reaming. Abrasive operations, that means grinding, wrapping, honing, and super finishing. Then we have straight turning, shaping, planing, plain milling, drilling. We told about broaching process also, where tool is just moving and its cut depth is increasing. Okay, We talked about the concept of generatrix and directrix. Okay, that means then machining with single edge tools. So we are telling the important angle like rake angle and then flank angle. And this is orthogonal cutting. And we talked about oblique cutting also. We told that different type of chips can be there depending on the not only the material but also the processing conditions. Okay, so for example, continuous chip with built-up edge, which is not desirable, and then discontinuous chip. And these are the factors, continuous chip if you have ductile material, discontinuous if you have brittle material, like that. We have other conditions also. Then we talk sometimes we do double turning also just to balance the forces in precision job. One tool is this side, other tool is this side. And then we have about this one. And this is a variation of surface roughness with cutting speed. Surface roughness decreases with cutting speed, then again increases, again it reaches maximum, and again decreases. It is something like that type of trend. Then variation of temperature with cutting speed. Then classification of chip by Ernst. Type 1 discontinuous, type 2 is continuous or even type. Type 3 is continuous chip with built-up edge. And so we are talking about a sawtooth chip formation. Sawtooth chip blockers. Why do we use chip blockers? In the tool, we should have some provision so that the chip can be broken. So you see that here, chip is getting broken. Chip is getting broken by these groups, etc. And then we are just doing by FEM simulation and all these things. So this was lecture 3. Then we come to lecture 4. In lecture 4, we talked about tool geometry, which is very important. How do you make? So in a particular tool, you have rake face and flank face. Now in the rake face, you will get crater wheel. Crater means basically a pit type of thing. So this is the wheel there. And you have this sharp cutting edge here. Flank wheel is there. Then worm cutting edge. And then typical lathe tool is shown here. We have different type of angles. That is in the SA system. SA system, we first tell back rake, then side rake, then end relief, then side relief, then end cutting edge angle, side cutting edge angle, and nose radius. But we have other one, tool point reference system. We are explaining that tool point reference system. We have orthogonal system, oblique system, and then so we have American orthogonal system, that means continental, then British system, MRS, international system. So in that, every system has 7 signatures, but sequencing is different. In orthogonal rake system, you get inclination angle, which is not there in other system. Maximum rake angle, NRS. And then I told that typical values of rake angle, etc. That suppose rake angle 5 to 15 degree for aluminum, 8 to 12 degree for steel, like that. And flank angle is also there. So these are the typical angles depending on tool material and workpiece material. Sometimes you put negative tool angles also. So this was told in the lecture 4. Lecture 5 is about this one, mechanics of machining, conversion of tool angles. So since you have got 4 main important tool systems and anybody will use any type of system, so it is essential that you should know conversion from one angle to the other angle. Okay, so here we are converting tool angles. Lot of trigonometry is there, which has been explained properly in the lectures, and you get finally this type of relation, some formula like tan I is equal to this much, and this is this one. So this is about how the orthogonal rake angle is related to normal rake angle, ORS to NRS. tan alpha n is equal to cos I tan alpha 0. Then it is tan alpha m. Maximum rake angle will be tan alpha m will be under root tan square alpha s side rake angle plus tan square alpha b back rake angle. Alpha b means back rake angle. So this type of things are there. Then multiple point cutter, multi-point cutting tools means we can have milling cutter. Here the teeth is put in the helix form so that all of a sudden there is not much load on one teeth and there is a smooth engagement and disengagement. That's why it is given helical form. Okay. So helix angle can be 0 also in some cases, but here it is given like that. And then you have again typical angles I am telling. Then twist deal is also there. So we have got typical point angle, average value of helix angle. Then we have set point angle. Suppose we are dealing mild steel, 118 is the typical dealing angle, point angle. And this is what that we told about cutting tool geometry. Then we came to that after telling the cutting tool geometry, mechanics of orthogonal cutting. Most of the times you have oblique cutting, but the orthogonal cutting is simple to understand. So in the beginning we told about this one, and it is a single shear plane model. There is shear across this, and therefore what happens that you have something like you bite a material of T1 thickness, it gets compressed and this side it gets a little bit widened, so its thickness becomes T2. So T1 by T2 is called cutting ratio, which is always less than 1. Okay, and it is related to shear angle phi. So this type of data has come from geometry actually. And chip thickness, so due to volume constancy, it shortens also because there is a plastic deformation, volume will remain. This one, so simplified way we are showing these forces: normal force, shear force, here normal force, and friction force. So we use a merchant circle diagram just to understand the relations. Okay, merchant circle diagram is just for ease of understanding. Otherwise, without that also you can find out that how the components are related, and they have been given by this type of formula. You can have effective coefficient of friction, and then you can find out that total power, and power can be differentiated with respect to angle. Okay, so this is WC with shear angle. So you to minimize the power, in other words, we have to maximize this one, and this you differentiate with respect to sin phi, and then you say that okay, this must be the power. So you need so that is what we found, that some relation of FC. But you know that this model has got poor agreement with experiments because we have not considered that fracture concept. So P.W. Bridgman proposed that actually if there is a compressive force acting on a surface, then its fracture resistance will improve. So based on that, he has given that relation, and you differentiate and you find out that C is equal to cot inverse K. Now we also have discussed that what is the effect of cutting speed, rake angle on cutting force, that if cutting speed increases, then cutting force generally decreases, cutting ratio increases, that means it becomes closer to 1, and rake angle increases means cutting force again decreases. Okay, and then these are shear angle relations. First Ernst and Merchant give this type of relation between shear angle, friction, and rake angle. Then they give a second solution. Then Lee and Shuffle, based on slip line, they have given different solution. And this one. There is another way to calculate the forces, that is based on the specific energy, that how much energy is required to cut this thing. And we are also mentioning that size effect, that actually size effect is very important. That means sometimes if you have to machine a very less thickness chip, then the force may be more also. Okay, so that type of specific energy is dependent on the size also. And we give numerical example. This we have already explained. So these are this one conditions for orthogonal machining. So this was told in that lecture 6. Okay, in lecture 7 we have told about this one, mechanics of machining, strain and stresses in orthogonal machining. If you know the force and you know area, you can find out average stress. But one important point here, we told that on the tool you get maximum normal stress near the tip. Then it gradually, in somewhat quadratic fashion, it keeps on reducing, and shear stress up to some distance, it is constant type of thing. This is sticking region, and then it becomes sliding and it becomes zero. So this is how that it goes. But then we just define that average is something are equivalent Coulomb's coefficient. But as such, Coulomb's model is not applicable for machining. We are also telling that suppose you, in general also, if the normal force is much more, then friction force doesn't change with the force. Okay, that means Coulomb law is valid in the beginning, but after that it saturates. So we told many models like Benham and Beige friction model and velocity dependent friction also, that friction force is dependent on the velocity. That means velocity increases, then the friction force decreases. We talked about shear stress, we talked about normal stress Fn by a sigma s, we talked about shear strain, we talked about shear strain, chip velocity, shear velocity. We talked about some problems based on some technical paper by Victor P. Estcourt in a journal in 2002. We told that single shear plane model may not be adequate. His arguments that these type of things are not possible, and there are many issues in the velocity diagram, etc. Also, he also says that friction coefficient cannot be constant. So other models also have been discussed, like Dix model, Joroj model. Instead of a single shear plane, you have zone basically, Joroj other model, and like that. So we discussed about these type of things. Then we go to lecture 8. Here we told about experimental study and some other models. We told about that sometimes we have negative rake angle. Now just see, it is experimental investigation on cutting characteristic in nanometric plunge cutting. So it is single crystal diamond tool, and this is about this one. If we want to study stress strain behavior, sometimes we made circular grid and see the distortion, and this circular grid may become ellipse. Based on that we can calculate the strain. So many methods of experiments have been discussed, but then what happens that we told about Atkins model, where he has considered energy for creating new surface. Okay, so he gives a concept of some fracture toughness. Atkins model has been discussed. Empirical models are there, like KT to the power A, W to the power B. Then slip line method is there, that we assume that material flows in it basically slips on certain lines. So this type of thing was discussed. And then we discussed about lecture 9. Okay, so in the lecture 9, we talked about ninth lecture. Here we talked about force relationship. What are the different type of ways to calculate the force? So we have analytical model like Merchant's force diagram, etc. By that you get some idea. Merchant solution. We can have experimental way. So basically you will get empirical relation. But one can have mechanistic, which is basically something like hybrid type of things. Some coefficients you take from experiment and some analytical things also you apply. The numerical method like FEM, etc. So these are the methods which are employed. So this is an interesting observation. How do we calculate power for plastic deformation? कौन है कौन है कौन हाँ कापी देखना क्या नहीं तुमको अच्छा नहीं जया को वहाँ 2 मिनट बैठ लो 2 मिनट बैठ लो अभी यहाँ बैठो 2 मिनट आ जाओ मेंबर बोलो ओके सो दिस इज फाइनाइट एलिमेंट मॉडलिंग Hello? Hello? तो ठीक है, okay, fine. So little bit okay. Acha, one person only asked in YouTube, he needed more solved examples, okay? Discussion in that, maybe for him, I'll discuss that, okay? Maybe that, let us go to, say some early question papers, okay, like this one, okay? Suppose we go to assignment, I discuss that something, assignment 4 has been done, na? It is from old set actually, okay? And I am discussing because he said that more solved examples, he is facing some difficulty in doing the problems. So I am just coming to the problems, okay? Now suppose in an oblique cutting process, okay, is it not, it is shown here or I have to share? I think I have not shared yet, okay? Yes, this is it. Okay, let me share my screen and after that you tell that whether it is visible or not. Okay, entire screen. This is share. Okay, this I can hide. बताइए, is it visible? Hello? तो visible assignment 4, okay. So I am discussing that, because one student उसने लिखा मैसेज कि सर हमको है ना प्रॉब्लम में दिक्कत होता है, हिंदी में ना उसने लिखा, ओके. So I am explaining that maybe he's from Bihar somewhere, okay. So in an oblique cutting process, the inclination angle is 6 degree, chip throw angle is 5 degree, normal rake angle is 7 degree, the true rake angle is this one. So there should not be any difficulty because these are just the formula based question about true rake angle in oblique cutting. So it is given like this, sin I, sin eta c, cos I, cos eta c. Only just you have to put the value and then you take this one. So this problem was of that type. Like that I will be telling some typical examples. Okay. Now these are also formula based question. In oblique cutting, mostly they are all formula based question. But let me go to assignment 3. Because there may be something conceptual also. Okay, assignment 3. Okay. Now in assignment 3, you have to do problem. Okay. Suppose thrust force in an orthogonal machining is 300 Newton and cutting force is 500 Newton. If the rake angle is 10 degree, then the friction angle is. So now you have been given thrust force, which I am indicating by FT 300 Newton and cutting force is 500 Newton. So you can have, now you have to find out in the rake force how much force is there. Okay, friction angle, because they are asking if the rake angle is 10 degree. Okay. So you have to find out friction force. So friction force is related to cutting and thrust force in this manner. This is also relation you can find out from merchant. FC sin alpha plus FT cos alpha and N is equal to FC cos alpha minus FT sin alpha. Then you calculate that this is F and this is N. Then coefficient of friction will be F by N. But the friction angle will be tan inverse of the mu. Okay. Because tan of the friction angle is equal to mu. So tan inverse mu is equal to 41 degree. So this is also basically based on the formula, but one should know the definition of friction angle. Okay. If friction angle is theta, then coefficient of friction is equal to tan theta. Then yield stress of a material without strain hardening is 400 megapascal. If the friction factor is 0.3, then the frictional shear stress is. So frictional factor is a concept that actually yield stress. So frictional shear stress will be the product of yield stress and friction factor. Okay, no, it should be yield shear stress actually, yield shear stress. That's why I have made it red. That means there was some mistake. Suppose you give 0.3 into 400. So this comes out to be 120 megapascal, but this is the yield stress of a material. but generally it is defined as M times K. Friction force is M times K, where M is the friction factor and K is the shear yield stress. Now, what will be the shear yield stress? If you consider one Mises criteria, then shear yield stress will be 400 divided by under root 3. Okay. Or otherwise, by Tresca criteria, you can also say that 400 by 2, that means 200 megapascal. So like that. So this is again that concept, this one, because so far in school you just have used the Coulomb coefficient of friction, but this type of model doesn't work in the when there is a plastic deformation, etc. So there is a heavy load is there. So that's why you have to say this thing. So one question was of this type of thing. If the friction factor is 0.3, the equivalent Coulomb coefficient of friction is given like this. So this was also like this. So like that, each and every questions you have to do. Let me just tell the previous years, even that, long back, what we considered that exam paper also, we can say that, okay, we can discuss something like in 2021. So in 2021, we have this one, okay, set two solutions. Okay, suppose this is like that. So it is okay. So it is. Let me just discuss. Okay, set two. So we'll have questions like this type of thing. Even multiple choice questions like assignment, it will come, but it is from the previous year's question paper. Okay, that it is about this one, set 2, 2021. Okay, fine. So here, yeah. Suppose a wedge of included angle 2 alpha is indented into the material as shown in the figure. So it is being indented for very small value of alpha. The force normal to wedge surface N is related to indentation force P in what manner? So actually P is equal to, we have written 2 sin alpha into N, because this is also basically based on the formula, but little bit twisting has been done. Okay, what twisting? That we are telling that it is a very small angle, so that means sin 2 alpha is equal to 2 alpha, because 2 alpha is in radius. So therefore B is equal to P by 2 alpha N. Okay, so like that I am telling, if there is any difficulty, then during the interaction also, while in assignment, you can again ask some detailed explanation and we can send. But I am just telling that it is not very difficult. Okay, so it is something like low-day conducted experiments on thin tube subjected to internal pressure as well as axial force. So this is just theory question. And sometimes in numerical, you may have like this, okay, numerical question, yield stress of material, because we will give that as per guidelines, we will give many questions straightway even from assignment. So yield stress of a material is 400 megapascal. It is subjected to pure shear stress. The value of tau at which it will start yielding as per Tresca criteria. In Tresca criteria, shear stress is 50% of the yield stress. So therefore it will be 200. But if it was one Mises criteria, then I would have divided 400 by under root 3. Okay. Similarly, that that a rod of length 1 meter is elongated to 2 meter. To engineering strain. Engineering strain is what? That it is basically final length divided by initial length, and then you take the logarithmic natural log of that. So it is so we have rod of length 1 and it is elongated. So you have got 2 divided by 1. So it is basically ln1. Okay, that means that ln1. Okay, that means natural log. Don't do that log 1. Log 1 means it is 0, but ln1. So ln2 2 by 1. So ln2 basically 2 by 1, not 1, because 2 meter. So you don't do log 2 will be different, but you do ln2. ln2 comes out to be 0.693. So this is natural. This is 2 strain, but we are talking about engineering strain. So engineering strain is change in length divided by initial length. So that is 2 minus 1 divided by 1. So that's why that the answer is basically 1. 2 minus 1 divided by 1. That means answer is 1. Not 0.693. 0.693 value has been given to confuse. People will think that, okay, it may be that ln 2 by 1. Okay. That is, if I change the question, suppose I change the question, I say the 2 strain in the rod, 2 strain in the rod is this one, then the same thing will get changed. Okay, this will get this one. It will be like that. It is this one. This will become the correct answer. Okay, this will become correct answer. So that is what that you have to carefully understand that. In an orthogonal machining, shear angle is 45 degree and rake angle is 30 degree. As per Lee and Shuttle theory, the coefficient of friction is. So it is, as per Lee and Shuttle theory, you have to see that what is the relation between that. Relation is given between phi, alpha and coefficient and the friction angle. So you get, by that relation, you get the friction angle, and you do that basically tan of that. Okay, tan means this is the friction angle. So tan times friction angle will give coefficient of friction. So like that, you have to assignment questions as well as these exam questions are not difficult. They are just based on the formula, but some concepts sometimes here and there. In an orthogonal machining, cutting force is 400 Newton and thrust force is 200 Newton. Rake angle is 5 degree. Assume that Coulomb's law of friction is applicable, then they are asking friction angle. Okay. Now you can do this based on the formula, but suppose, by the way, if it was rake angle is 0 degree, then it becomes a straight type of tool. So cutting force 400 Newton becomes the normal force and 200 thrust force becomes the friction force. So friction force, coefficient of friction will come 200 by 400. That means 0.5. But you have been asked friction angle. So therefore you have to do tan inverse 0.5. Okay. So like that, you can have different type of this one. Okay. So if there is so like that, these all problems are there. Just solve that thing. If you need, somebody needs some extra questions also, and request the extra questions also can be supplied to him just for practice. But you know that we are giving sufficient questions each week. This time we have increased the questions. Instead of 10, we are now giving 15 questions. Otherwise, we used to give 10 questions only. So for practice purpose. Okay. Is there anybody that here in this one has joined? Okay. That let me see in YouTube if there are any questions, then we have to answer that. Okay. Otherwise, now time is also coming. It is up to 5:15 only. So let me just see that who has. Yes, okay. Pass me some more calculation. You are facing something. अच्छा question. specify उपके not. एक राय में क्वेश्चन नहीं बनता है. Assignment में बहुत क्वेश्चन नहीं बनता है. एक ही राय का to help. So this is dear learners, please post your queries. Okay. So I think that here you watching now. Okay. So now only 2 people. So maybe okay. This one. Okay. So now what happens that we are showing 1 or 2 more questions. Otherwise, this is about that. Just that very simple type of questions also we are giving. Say for example, okay, a straight turning tool has a backward angle alpha b of 8 degree and a side cutting edge angle gamma is of 30 degree. For achieving orthogonal cutting condition, the maximum rake angle will be. So what we are doing, that orthogonal cutting condition formula, you have to put tan I is equal to this much. By that you will get tan alpha s, and then tan alpha m will be tan square alpha b plus tan square alpha s and then whole square, and this is 0.5. Okay. And sometimes we also give this type of questions which are based on just general mechanics. We have given feet force 300, radial force is 200, and spindle RPM we have given 1000. So if the total force on the cutting tool is 540 Newton, then the power available is how much? So what I am telling that once I have given total force I have given, so 540 square minus 300 square minus 200 square. Pythagorean type theorem will apply, and then you square and you get 426 Newton. And power can be known if we know the surface speed. So power available at the spindle will be in terms of the spindle speed, but here spindle speed is not given. So naturally that answer will be in terms of the spindle speed. That means force into velocity is the power. Okay. So how do we get the velocity? That means if we know the cutting velocity. Now cutting velocity, that means cutting velocity. So we have to know the cutting velocity. RPM may be given in. So you just say pi dn, and if you know the job diameter, then you can calculate cutting speed, pi dn by 1000. So like that. So in an oblique, this is also that based on this one. Okay. Young's modulus, etc. That about this one. Let me tell me some questions more, and then okay. So suppose even we go to this one. Which one of the following is not a subtractive manufacturing process? You know, sometimes some conceptual questions may also come. Grinding, upmilling, extrusion. So naturally extrusion is a metal forming process. It is not subtractive, it is not machining. Okay, other things are machining. If sigma y is the yield strength of the material, the radius of the Mises yield cylinder is approximately 0.8 sigma y. This is given in your chapter 2 write-up, so it is based on that. In a single point cutting tool, crater wear occurs at the rake face. Okay, flank wear occurs at flank face. That option is also there, but crater occurs at that. And then theoretical questions are like that. There is definitely one question will come on the wedge indentation. Wedge is indented in the material. Normal force is given. In this case, formula is same, but I have given normal force, and the wedge is 10 times the indentation force. So you have to calculate in included angle. So in the then here we have other type of questions also. See here that yeah, as per this one, say suppose the typical flow stress of material is K epsilon n. This is from chapter 2, simple thing. Formula itself has been given. At a strain of 0.1, the flow stress is 500 megapascal. So that means 500 is equal to K 0.1 to the power n, and 550 is equal to K 0.2 to the power n. Then the strength coefficient is. So how you will find out? You can do many ways. Either you take logarithmic of both sides, so you will get straight line equations type of thing. Okay. So this is about this one. Or you can do that, just to find out the ratio. So if such type of problem is there, you have to follow some procedure that says, for example, this is set 1, and if it is, I think 36 question, okay, question number 36. Yeah, so I am just doing that K 0.1 to the power n is equal to this thing, K 0.2 n is equal to 550. I am just taking the ratio of these two, and I am telling 2 to the power n is equal to 1.1. So n is equal to this much. So n is equal to means we are taking the log of both sides. So you got the answer. So like that you have to practice, then you can naturally get this one. So yeah. So like that there are many questions here. Say for example assignment set 2 solution. Okay, chip compression ratio. Sometimes we just twist a question a little bit. Cutting ratio is R, so chip compression ratio will be 1 by R, inverse of that. Cutting ratio maximum value can be 1, and in chip compression ratio minimum value is minimum value is 1. So this type of questions are there, okay. And it is about this is also a very typical formula. Shear angle, shear strain in machining. If we assume single shear plane model, so gamma is equal to tan bracket phi minus alpha plus cot phi, where phi is the shear angle, alpha is the rake angle. If rake angle is 0, then it will be tan phi plus cot phi. So it is suppose somebody has given shear angle as 30 and this alpha is equal to 5 degree. So it is tan 25 degree plus 1 by tan 30 degree becomes 2.2. So shear strain is in fact coming 2.2. Okay. And this is the relation between, you know, that shear angle and Merchant's first solution. Phi is equal to 45 degree minus half lambda minus alpha. So this relation is also different in different type of systems that I have already showed there. Okay. So this is what. So I think that now the time is over and we can conclude the session. Correct? Is it okay, Rekha? Pathak? Partha? Hello, Partha. So I think that, so is there any YouTube, is there anybody else there? I think that we have 1 or 2 queries came and I have showed them sample problems. Okay. So I think the time is also over. Only in between 5-10 minutes there was a disturbance. Okay. But I think that you can just see that in YouTube, is there any demand? Otherwise, I can conclude this session. Do they want to ask me? No more questions? Yes, yes. So I think we have answered that. Okay. We also have told that most of the questions are only formula based. Only thing because they have to revise some basic things like, you know, coefficient of friction is related to friction angle. Okay, tan lambda, such type of things. Okay. And in queries also they can ask, are they asking questions? No? Yeah. So in that you can explain, individual person who is having difficulty, he can ask, okay, he or she, no problem. Okay. So I am leaving now meeting, correct? Okay. Yeah. Yeah.